to Science 2.2. Remember, you can go to Beanstack, and at Beanstack, you'll be able to see this activity and get all the descriptions you need. At the website, at the McIntosh Memorial Library website, you'll be able to download all of the instructions you need for the surface tension experiment we're doing today and the density experiment. Now don't forget that Vernon Communications is being amazing this summer. Well, they're probably amazing all the time, but this summer, they're exceptional. They're helping us with all of these videos that you get to watch. So let's get started. First thing you want to always do is check to make sure you have all your supplies. So it says a shallow pie plate. Yep, we've got that. 2 cups of whole milk. Yep, I got it. Dish soap. Got it. Liquid food coloring. And you know what I had to do with the food coloring? I could not find liquid food coloring at the store, so I had to get this gel. Then I just added some water to it, and I made liquid food coloring. And then some toothpicks. So I'm going to move this one over there, and then we'll check our density experiment, just so we can kind of separate the two. And today, do you notice that I have this plastic down? Because I don't want it, if I drop some of the coloring, I don't want it to stain the surface I'm on. I don't care about this plastic, but I do care if my table gets covered. And you know what? I bet your moms and dads might care too. So it's always good to keep everything covered if you can. So toothpicks, and I put dish soap in a little container like this. So a clear container right here. Oil, got it. Sugar, got it. A half cup of water right here. A turkey baster, got it. And different objects that might float or might not float, so that we can check the density of those objects. So let's get started with our surface tension. So do you know what surface tension is? Surface tension has to do with liquids, and they have bonds in them. And those bonds like to be attracted to each other. But there are things that can make those bonds break. And when they break, stuff moves around. And so, let's see what happens. I'm not going to measure my milk. I'm just going to put it in here. Now the next thing I want to do, I'm going to kind of let this milk settle down a little bit, and you don't want to be bumping your table during this experiment. Then I'm going to suck up some coloring, and I'm going to gently put it on to the milk. And I'm using whole milk because that has the greatest amount of fats. And that makes the bonds a little sturdier. Looks pretty, doesn't it? And can you see how carefully I'm doing that? Now, the camera's going to come real close. And I am going to take a toothpick, and I'm carefully not bumping my table. And I am going to put some dish soap right in the middle. Isn't that neat? Now look at, let's just watch for a minute. Let's see what happens. Look at, does that look like it's spreading out? I'm gonna add a little bit more and see if we can make break. See, the surface tension broke there, so it pushed the milk out and the coloring. Whoops. I'm gonna do it over here this time and see what happens. Look at here. This one's cool. And then we'll see what happens. I don't know if you can see this on the camera, but I see stuff happening in this red. Looks like a jellyfish to me. Because look at how close the red and the green have gotten. And I see the red oozing out down here, moving back more to where it is. And see the soap right here? Yeah, it's breaking up. This time I'm not going to put in quite so much, and we're going to see if it makes a difference how thick the milk is. I feel like a real scientist right now. All right. Didn't seem to make a lot of difference, did it? I like the way the soap bubble kind of moves around. You know what else helps this experiment? If you warm up your milk just a little bit so it's more at room temperature. Mine I just took out of the fridge and it's very cold. So if you warm it up, you'll get a better reaction here. Now this next one is about density. And I want you to picture this in your head. Picture a small room, 4 sides, you're the only person in there. Doesn't seem so small, does it? Now let's add 50 people with you, or 49 more and you make 50. Now how does that room feel? So now you feel like, I don't have so much room anymore. And that's because the room is more densely populated. And so that is the same with different materials. They have more molecules closely packed together, and so it makes them denser. And so therefore, we're going to see what happens with density. So in here I just have some plain water. And we're going to make some sugar water. This water is a little bit warm because when it's warm, it will take in more of the sugar. And so you want to keep adding this sugar till it won't dissolve. So I'm just going to keep stirring. But look at, this is certainly acting different now, isn't it? Look at how it's surrounded the soap bubble. Got to keep adding it till it won't take any more in. You know what that's called when it won't take any more in? That's called the saturation point, and that means it has so much sugar in that water that it can't take any more in. It can't cling to any more. Looks like we're getting pretty close. I'll let that sit for a little bit and then I'll stir it up a little bit more. Because see, once I stop stirring, it gets a little bit clearer because some of it goes out. So I want to make sure I get that all dissolved. Then the other thing we're going to add down into this water is oil. See, now as soon as I stopped stirring that, all the sugar went away. So now we're going to add some more, because we want this to be completely saturated, holding as much of that sugar within the water as it can. Because we want to make it as different from this plain water as we can. Just a little bit more. It's getting close, I can tell. It's getting kind of thick even. You can see that it would be very sticky if I spilled it. So I'm looking and I see that it's not all in the water. Some of it has sank to the bottom. So that's telling me we're very, very close, because some of it can't dissolve. This is a mixture too, because it's more than one thing. So now I'm going to take my baster, suck up water. And I'm going to move it really, I got to move this closer to me. And I want to get close to the top, but I don't want to put it in too hard. Slowly, slowly, slowly. So now I'm going to add some more. I don't know if the camera can pick up on this, but you can see how they're separating. We'll see. This is a tricky part about this experiment, really. And the next thing we want to do is add oil. We have to suck this up again and put it in. See, isn't that cool how the oil stays right on top? The oil part's pretty easy because it goes down and comes back up. Now, I'm hoping we have 3 layers of liquid in here. It's a little bit tricky to see if we have a different layer between the sugar water and the water. I could have made that a different color, and that would have helped. Now, I got together 3 objects. A paper clip, some tomatoes, and some birthday candles. And we're gonna see what happens when we drop these in. Let's try the paper clip first. I'm gonna get it down there. Try to go in about the middle and drop it. It's way on the bottom. Is that what you predicted would happen with a paper clip? Yeah, me too. How about let's try the tomato. I'm gonna try the smaller tomato first. The way I have to hold the tomato, it's a little tricky to get my hand in there. That floats on the oil. Can you see it? Let's try the bigger tomato. Nope, they both float on the oil, don't they? I wonder what I can do to find something that will float in the middle. Wow, a candle certainly floats, doesn't it? You know what I wish I had? I wish I had a grape. Or how about a raisin? I wonder what a raisin would do. Let's see. Maybe I have one in my cupboard. Let's try a raisin. I don't know, raisins are pretty dense. They're pretty hard. We'll see. No. Oh man, it floated for a minute, didn't it? How about a cover to one of these? I don't know if I'm going to find anything today. Let's see. Nope. And it's even filled with water. It looks like it's a little boat. Let's see if I can push it down a little bit. Nope. Darn it, I didn't find you something good to float in the middle today. But you know what? That's what really good scientists do. Good scientists keep trying till they get it right, or until they find out something. Well, I know tomatoes are going to float in oil. Maybe that's why they taste so good in vinegar and oil. I can see that there are 3 layers here. I bet it's not showing up on the camera, but you can see this is a little different color down here. So this is the sugar water and this is the water. All right, well that's science for today, but you know, I only did this a little bit. You can go ahead and play around with all of these things as much as you want to. And I would definitely try to find a whole bunch of objects to put in there and see what you think will float and what will not. Guess what tomorrow's activity is? Homemade ice cream and homemade hot fudge. So awesome, huh? All right, and we'll see you tomorrow at 3 o'clock making homemade ice cream and homemade hot fudge.